Hi, I'm John. I'm John Schneider. I'm a Spring Team developer at Pivotal. I'm a teammate of Rob's here. Really just joined Pivotal this year. I was previously a Netflix engineer before that, and even before that was an insurance. Worked for an insurance company, so I've seen two very different companies in terms of how they operate infrastructure and software, and hopefully I can use some of those learnings here. I'm here to talk to you today about Micrometer, which is a new application metrics instrumentation library that is going to be the metrics system that underpins Spring Boot 2. And we've also taken it and bridged it back to Spring Boot 1.5 something. I'm not exactly sure where the boundary is, but some version of 1.5. So who's ever heard of like drop wizard metrics, those kind of things? Yeah, drop wizard is a pretty common one. You can think of Micrometer as an alternative to drop wizard, except that drop wizard is focused on hierarchical systems. We'll talk about that a little bit later. Micrometer, I like to say it's the SLF4J of metrics instrumentation library. So the idea is you record you instrument your application in one way without vendor lock-in, and then you just plug in different implementations as you explore and try new monitoring systems and learn about them. So that's kind of the overarching goal. Spring Boot 1.5, you may know, and Spring Boot back to something, I don't know when it started, actually has drop wizard metrics at its core. That's what's in Spring Boot Actuator right now. In Spring Boot 2, we've ripped all of that out. All that API has just been removed and replaced with Micrometer, so you'll see it coming soon. This is cool. I was from Missouri originally. It's kind of exciting for me to introduce a tech like this to the Midwest first. I really like that. I like coming to Kansas City. This is the first public talk, really, on Micrometer. It's not like a secret or anything, but it's the first public talk on it. So being a Midwest guy, it's cool to me to be here and present it to you here first. For those that are interested, GitHub site, Micrometer metrics/Micrometer, you'll be able to find it there as we go along. My wife and I had a baby recently. It's our third child, so we have 3 under 4, and it's one of those you feel like you're drowning and somebody hands you a baby thing, if you've heard that joke. We got through that whole experience, and little Zeke's doing great and everything. About 2 or 3 weeks later, Christine gets a call from the hospital cafeteria, very specific, a specific department within the hospital, and they say, hey, would you like to take a survey? And she says, oh boy, would I like to take a survey, because man, that food's terrible. Anybody's been it's just like typical hospital food, right? It's terrible. And she's just waiting for them to ask the key question, how was the food, right? And they say, well, was your food delivery timely? That was the question they asked. She was kind of prepared with an answer and just got cut off. And just, well, yes, it was timely. It was always timely. It was a great, and I thought about that. There was a lot of things I thought about in this hospital experience related to metrics. It's not good, but they didn't ask the right question, right? They didn't ask the question about quality of food, or maybe they don't want to know. But they're not going to get a useful answer by asking a question like timeliness. And I feel like wittingly or unwittingly, that's how a lot of us are with our application metrics right now. We're shipping metrics on remaining disk or something like that, and it doesn't have any operational bearing on whether or not our end user is having a horrible time or not. So that's what we're going to try to help with. I'm going to try to give you 4 takeaways today. They're kind of random. 4 takeaways about Micrometer and about just kind of things I want you to know generally about metrics. Let's get right into it. So takeaway 1, Micrometer is expanding the types of things that we can record. So if any of you are familiar with the Spring Boot Actuator metrics right now, you only get 2 things. You get a counter and you get a gauge. And that's it. And both of those are single metric things, it's a count and it's a value, and that's the limit of it. So Micrometer is expanding the metrics primitives you can interact with to a bunch of different things. You get counters and gauges, of course, but you also get timers, and timers are like this composite thing. Timers, when you time a block of code, it ships the count, it ships the max, it ships the total time, it can ship percentiles, it can ship histograms that can be used to generate percentiles, all sorts of things that come out of that one metric. So you don't have to do it manually. Distribution summaries are similar to timers, but they're used to record non-time related things like response or request payload size and things like that, usually like storage type related things. We've got things like long task timers. Long task timers are really specialized, but can be used to alert you quickly when one of your batch jobs is going like, it's supposed to take 10 minutes and it takes 8 hours. If you just time it at the beginning and the end, you don't get the alert on that thing until 8 hours has elapsed. A long task timer will help you get that alert at like 11 minutes instead, and you can react to it, that kind of thing. We have these weird specialized constructs called function tracking counters and function tracking timers. That way you can use to reach into kind of old legacy metrics APIs, such as you find in Guava, for example. The Guava cache emits counter and timer related things around its cache, but it always gives you the accumulated value. Congratulations, your service has been alive for 4 months, and you've done 1 billion requests against this cache. That's not actionable. You want to know, in this last 10-minute interval, how many requests did I execute against this cache? And was that abnormal or was that not abnormal? So Micrometer helps you smooth over those old things as well. There's a big distinction between Dropwizard and Micrometer. Micrometer metrics are multi-dimensional. I kind of have an example here of what that looks like from an API perspective. Here's this meter registry interface that you interact with. This is part of the SPI surface area. You can add like common tags to your application saying, I've got host, which is John's MacBook Pro, and I've got a stack, which is like development or prod or something like that. And then you have a timer on, say, database calls. You can add a dimension on what table you're interacting with or something like that. So the point of these tags is when you say, I'm timing database calls against a bunch of different tables. When I look at it from the perspective of the monitoring system, I can look at my request latency against my database generally, or I can start to drill down and I can say, what was the request latency of calls against the sales table, or perhaps the calls against the sales table only in prod, or only in this region, on the West Coast versus the East Coast, or those kind of things. So the idea is to be able to arbitrarily drill down on different dimensions. Absolutely, yeah. So any tag you can really come up with. We like to say low cardinality tags. So like user would be a bad one because there could be 1 million different users. You can't really meaningfully explode that. But let's compare this to like the Dropwizard case where we are right now. You kind of like have a lot of people have a similar thing going on with a hierarchical system like Dropwizard right now, where they take a metric and they name it like this. So you'll have like endpoint.name.users, and you just kind of like keep dot appending these things on the end, .response.500, et cetera, et cetera. You keep going on and on and on. And for the like graphite type monitoring systems that Dropwizard ships to, you can do some level of dimensional drill down via wildcarding. So you see an example here where I select all the 500 responses by wildcarding the endpoint and wildcarding the whatever comes after the response. I think it used to have another tag on there. At any rate, you get the idea. Let's go back though and let's add another dimension to one of these. So let's say we add exception or something like that as another piece to microservice 1, so that you have a new name. And now let's add HTTP method to both of them. And this is what happens. You wind up with these two metrics, where you've kind of got the original, response.500, and you've got method.get appended to the first one. But down below, you've got that exception thing that we added to one and not the other. And now method is, kind of later on in the name. And now I can't wildcard on method anymore. So these, because it's like in a different position in the name. So these hierarchical metrics are really limited in the degree to which you can do dimensional drill down. Luckily, and this is what I say about Micrometer, Micrometer is a dimensional system first, but we can support these hierarchical systems just by taking all the tags, sorting them, and appending them to a big name. So it's easy to go dimensional to hierarchical. It's impossible to go hierarchical to dimensional. That's kind of where we're at. So I think all this said, takeaway 2, multidimensional metrics is the big thing. Some monitoring systems you may be familiar with, like Prometheus, are dimensional by their nature. Datadog is, Influx DB is. So, it's like, rather than having a weird impedance mismatch where you're trying to take a hierarchical name and break it up into dimensions, you kind of support that structure natively. So the boring 2 are out of the way. Takeaway 3 is really short. The idea is to instrument without vendor lock-in. We mentioned this before. So because you interact with the SPI, you act with just like the meter registry interface. The actual implementation of that interface is something that you can select in typical Spring fashion. You can select at runtime, via a property selection, as provided that the registry implementation is on the class path. And what we're trying to do is build in support for all the most popular monitoring systems. So to date, we support Prometheus, the real popular dimensional system, Netflix Atlas, Influx DB, Datadog. We support like the StatsD agents for Datadog and Influx, which is called Telegraph. By the way, Influx, Telegraph, Influx, C and K. I don't know what C and K are, but they call it the tick stack. I had to imagine these people are not from the Midwest. Like who wants to call their chief product the tick stack? I don't know. It's nuts to me, but and then it supports the original Etsy flavor as well. And then of course we support the 3 like traditional hierarchical backends like Graphite, Grafana, Ganglia, those things. And the idea, again, like I wouldn't recommend somebody starting out new use a hierarchical backend, but we recognize that there's a lot of that out there. You can instrument now. You can still use that system. You can use it to great effect, and then you can gradually move yourself on when you need to. We also intend, of course, before the first GA release of this on November 20th. Here comes my like super optimistic self. We're going to add New Relic. We're going to add Colic D backends, so like the more esoteric monitoring systems like Remon are going to come in under that. We're going to add Elasticsearch metric beat. So, I think if there's one out there that like is your favorite, you don't see it listed here, let me know. Yeah.
So this is probably an ignorant-based question, but how does it relate to Zipkin? Is Zipkin a backend that it might support?
Yeah.
Or is it
Yeah, this is a good question. The question is about how does this relate to Zipkin? And maybe I should have said this earlier. Micrometer and application metrics in general is like one leg of what we call the observability triangle. And the observability triangle, it's almost like a line and a point rather than a triangle. It's like logging, tracing, and metrics, application metrics. And logging and tracing are really closely related in some ways because when you look at tracing information, you're looking to diagnose, what were the constituent timings that went into this total user experience end to end. I spent this much time in this service, I spent this much time in this service, et cetera. Logging is kind of similar. There's an affiliation with them. When you're tracing the start and end of a service, there's probably also like a log message that's associated with the start and end of that thing. And so you see that a system like PCF metrics, affiliates those two together. And then metrics is like this thing on the side, which you use to understand the more macro picture of like how is my system looking overall, but you don't use it to drill down on a particular request and understand what the constituent parts. And similarly, you can't really use tracing to get a notion of how is my system performing now relative to 10 minutes ago, if that makes any sense. So Zipkin is a tracing, is part of the tracing triangle. Any other? I should stop here. We've gone through 3 takeaways. Any other questions on where we're at so far? This is the exciting part to me. Takeaway 4 is exciting. I saved the best for last. It may not be exciting to you, but I think it's exciting. Let's talk about something specific. So, I kind of mentioned before, I gave you the cafeteria example. where they asked her what the timeliness of the food was rather than the quality of the food. Something, when you think about the things you could potentially monitor, the first thing that's going to come to your mind, or first thing that comes to my mind is, well, I've got a microservice with a bunch of HTTP endpoints. I want to know what the latency is on those endpoints. Seems reasonable, right? How would you monitor something like that? Like, what kind of statistics would you look for from a request endpoint? What do you think? I want to hear some ideas here.
Response time or mean response time?
Mean response time. That's one. That's a good one.
Or error rate as well.
Yeah, and yeah. So an error rate, sure. So we want to be able to divide like successes versus failures. But you're kind of hitting on the kind of thing I'm after here is what kind of statistics would you want? So mean is one of them. What else might you want to get out of latency when you're looking at latency? Any other? What's that? Yeah, so mean over a period, that for sure, yeah. I'll give you two more to kind of get the juices flowing here. Count, the throughput is one. Max response time would be interesting. What else could you think of?
Maybe standard deviations as well.
Standard deviation, yeah. Thank you for saying that. Gosh, I'm so excited that you said that. You have no idea. Great. What else? Yeah, and those would be tags. Those would be tags for sure. Yeah. The only one that we haven't really talked about. Well, there's min, which who cares really what your min response time is, right? The only other one would be like percentiles. So we talked about mean. The 50th percentile is of course the median. To the degree that either one's a good measure of centrality is debatable. But then you got things like 90th percentile, 95th percentile, 99, etc. That pretty much covers it. So we've talked about a lot of, count for throughput, mean, median, percentiles, standard deviation. Let's go through some of these. Like the median, or the mean, really, is what most people latch onto first and graph in their systems. And if you're using like a system out of the box, it's probably going to be the thing that it is best at displaying. It's kind of like entirely worthless because it only shows you, when you think about it, it only shows you the best half of your user's experience. It shows you like all the percentiles up to the 50th, and then everything beyond that is just not included. And yet, and this way, and not to dig on Drop Wizard in particular here, Drop Wizard is deeply focused on mean as a measure of something you should measure. In fact, they give you like 1 minute moving averages, 5 minute moving averages, 15-minute moving averages, as if this is the thing that you're supposed to be looking at. Secondly, on the standard deviation thing, timers and distribution summaries in real life are strongly multimodal in general, not normally distributed at all. And you'll see an example here in a moment of just how quickly standard deviation can go way, way wrong when you're looking at that. High percentiles, even if you're looking at like the 90th percentile or the 95th percentile, you're still missing 10% or 5% of your users are experiencing. And remember, like if you think through the math, like let's say I look at the 99th percentile of my request latency. That means that there's 1% of the population out there I'm not seeing. And if I see that like whatever could be happening up there could be bad, if there's a 1% chance of something bad happening, it kind of seems like that's only 1%, right? How bad can it be? If your service is taking, like let's say somebody's interacting with your service 100 times an hour, there's a 63.4% chance that they had a bad experience in that hour. When you think about that 1%. So these kind of things, like mentally, we build up these numbers, like 99. It's like, oh, it's good enough, and it really isn't when you think about it. And yet, and I'll pick on another monitoring system now, Telegraph, the Influx, our famous tick stack, they ship the 90th percentile. Right? So I said there's a 63.4% chance of something bad happening in the top 1%. they're losing visibility on the top 10% of requests coming through. It's really interesting. I would say this, like looking at the 95th percentile is good, and this is one of the things Micrometer is going to try to encourage. Look at the 95th percentile, but also plot the max and make sure you know what your worst case user experience is. And yet, Prometheus, the most common dimensional metric system out there, doesn't support max as a concept. There's no way to record max when you're shipping to Prometheus. So Micrometer is taking these things, and we're dropping down support for max on Prometheus and all the other systems that don't support it. We're dropping down percentiles on systems that don't support it. So that's where this like SLF4J metrics thing comes in. We know what you really should be looking at, and we're going to drop down support for those on all the monitoring systems you might be wanting to get. Let's look at an example. I think I want to show you just how crazy this can get. I have a little server or service over here. I should go into presenter mode here. Boom. I've got like a little Spring Boot app here, a little controller, an API, like a totally fraudulent API endpoint here, where we're getting like we're just sleeping for 200 milliseconds. So it's
I'm not sure we're seeing the same thing as you.
not at all, which is interesting. Let me. That's great. How about that? Woo! That is huge. Yeah. I wonder if you've been doing that the whole time. You know, you just haven't. Yeah. Yeah, that's great. Yeah, so we've got like a little request endpoint here. No big deal. Returns, you know, it just sleeps for 200 milliseconds. And then I'm simulating something bad up here, and not very frequently either. I'm saying that like, you know, because I'm going to chuck a whole lot of requests at this thing in a moment with the Gatling test. And I'm going to say once a second, I'm going to give you like a 900 millisecond response time. Okay, and you know, these are going to be roughly 200. It's not always going to be a 200. But like once a second out of like, I'm going to ship like 1,000 a second at this thing. And we'll just see. We'll see like, what does the 99th percentile look like? What do you think? Like, what do you think the 99th percentile is going to look like here? Any guesses? Nobody's bold. You know, if I had asked, I would think like maybe like 400 or 500, something like that. You know, kind of a little bit above the normal 200 millisecond response time, but not too bad. We'll see. Whew. Man, the ratio here is crazy. Let's start this guy up. If I can swap back over here. I'm going to start a simple sample. So I'm just using a Spring Boot app here where I'm not actually shipping the metrics anywhere. I just create a little endpoint here at the end that gives us the important stats for this particular endpoint. This is a weird thing. Let's close that. Okay, so it's all started up. I'm not executing any load against this, so if I look at the stats, let's hope this works. Whew. These values are intervals, so they'll show up eventually. But yeah, I mean, so right now the only things that are happening are the bad things. So 50th percentile is around 900. That's what we expect. Let's start up the load test. Eventually you're going to get going. Yeah, it's rolling now. And so we'll just watch. So pretty quickly, you know, the 50th and 95th percentile drop down to about 200 something. You can see that. The 99th is still up there at 900. Now we're starting to get the count and mean maxing out there rolling over. So mean, you know, when it comes in, this is interesting, right? The mean is already at 211, right? As a measure of centrality, that's really interesting because, you know, we spent a bunch of time there just sending bad requests to this thing, and it's just totally lost already. And look at this. After a few seconds, 99th percentile says 213. So if I was just looking at percentiles here, the bad user experience that's happening once a second, it's gone. I did the standard deviation on this, by the way, a little earlier. Had to do it manually because I didn't build it into Micrometer. The standard deviation was about 69 milliseconds, which is kind of high, really, when you consider, like, it's pretty high. And so with a 69 standard deviation, this, like the 900 thing that we're seeing once a second, that's 10 standard deviations away from the mean. So, if this were normally distributed, what that amounts to is basically like the probability distribution would say that you should expect to see one of these every 69 billion times the Earth has been alive, right? Like that's how infrequently it should happen. Like the Earth should like have created itself and gotten to this point 69 billion times before you should see that thing again. And we're seeing it once every second. And so and this is unfortunately like really the case on pretty much every timer. I know this was kind of like an artificial example, but you get things like system pauses, like GC collection and things like that, and boom, you get a pause that's just way out of the normal, the mean. Strongly multimodal. Some people think like, well, maybe distribution summaries like request payload size, that'll be normally distributed. Generally not. They tend to fall off really sharply on the left. Yeah.
So you were talking about the various things that will cause these abnormalities. How do you relate those then to the events that are causing them once you have the metric?
Yeah. So I mean, the first thing is knowing the metric, and that's just like looking at the max and looking at 95th. So getting an idea of what most people are experiencing, and also knowing what your worst case is. That's a key takeaway. But yeah, relating them is going to get down to like, the normal like tracing versus tracing logging. You like go back to the other end of the triangle there. You go to the line and you start looking at that. You look at performance monitoring tools and things like that to understand where that is. Yeah.
And maybe this is with more of the advanced graphing than what you can sew with just the endpoint like that. But like, does it also sew like maybe you just did have that one really bad request, but then your other 99, everything else was just fine.
Mm-hmm.
Like is there something that kind of sews like once you get past like certain standard deviations, not in a number of users, but in how far from mean?
Yeah.
Like does it sew how many of those requests hit that point? Like is there anything a metric like that?
Yeah, and so in Micrometer has a lot of these things built in. So what you can do is you can, like one of the things that's built in is you can define SLA buckets. Like say, 95% of my users should experience this, 99% should experience this. Nobody should be worse than this. Okay. And what it'll do is it'll accumulate counts to those buckets. And so you can look at that bucket relative to the total and say, hey, 1% of my users are experiencing something horrible every hour. And kind of get a notion there. But yeah, the key takeaway is like, and this is why I want you to use an instrumentation system that is kind of aware of these things, because we're going to drop down support for all the right ways of monitoring request latency, and allowing you to do it on your monitoring system of choice. That's key takeaway number 4. And then so lastly, I'll wrap up here because we just go on with random things here forever. But so like having a monitoring system is just the first step. Like I want you to be able to collect good application metrics and create good dashboards and things like that. That's great. I want you to be able to create alerts that wake you up in the middle of the night when things are going really badly. But the future state is more exciting to me. It's bringing things like automated canary analysis. From my time in Netflix, where they're open sourcing that real soon. And what that allows you to do is you stand up 2 clusters, one with the new code, one with the old code, direct the portion of traffic to the new path. And this automated canary analysis will do this like complicated Mann-Whitney U-test and say, looking at the metrics from both these systems now that we have them, I can tell, yeah, this canary's good, or this canary's bad, and I should stop sending traffic to it. Things like that. Rob and I were talking earlier about intrusion detection systems. We can start at Pivotal to do more complicated things around, hey, if Spring Security is unauthorizing a massive amount of requests suddenly, and it wasn't before, there's probably something going on, that you probably want to know about or take some action on. So those are kind of things. Dynamic alerting, real exciting prospects coming out once we have these basic things.
So
Yep.
you mentioned that you guys are ripping out all the actuator code.
Mm-hmm.
So how's like software compatibility like, what's your data sources, and let's say you
Mhm.
then add in your own custom, like, I need to know also if this thing's out, this,
Sure.
if I'm up or down.
So health checking is a separate mechanism,
Okay,
and that's still present.
okay,
So this was really ripping out like counter service, engage service,
okay, yeah, that,
and the regular like slash metrics stuff. Anything that we automatically recorded for you, like CPU time, Spring integration stuff, cache metrics, all that stuff, has a corollary in Micrometer, so you don't lose anything. It just looks a little different.
okay.
So that's good. That's basically what I have. It's open for questions really at this point. Yeah, Rob.
I don't know if this is possible, but can you show like what it looks like in one of these other toolings that it integrates with?
Yeah, let's do some
That,
freaking live coding.
spot?
Yeah, it's okay. It's a challenge. We'll take it. I'll show you the one I'm bad at. How about let's start with that one. Prometheus is kind of popular, I think. Let's see if I've got Prometheus running. Oops. Let's see if I have Grafana running. Look at that. Sure. Oh yeah, these are some of the other things I didn't mention, but like all these monitoring systems, they have their own naming conventions. Like one uses underscores, one uses camel case, one uses dots, one uses blah, and they all have their own expectations around base units too. One expects seconds, one expects nanoseconds, one expects milliseconds, one expects microseconds. You just never know. Micrometer glosses over all that for you too. So it knows what the base unit of time is on the back end, so it automatically scales values to that before shipping it. It knows what the naming convention of the back end is, and so it takes a name and it normalizes it to the naming convention of each monitoring system as well. So what started as just http.server.request in Micrometer looks like this, because that's what the guide for Prometheus says it should look like. Here's count. That's one thing I don't like about Prometheus is it's like, by default you get an accumulated value, which, I can't really create an alert on this, because what would I put my alert at? If I put it at 12,000, I'm going to blow past it, and then, beyond that, it's kind of... So, in Prometheus, you can take these things and rate normalize them. Can I make this up? Sure. Yeah, the units are really terrible here. It's like the unit is 101 to 102, but that's about right. I mean, throughput on this API endpoint is about 100 requests per second, because that's what I set up in my Gatling test, and you can see that happening here. You can do more complicated things like, if we got this turned on, like histogram quantile, horrible name. Oh yeah, bucket. Is it buckets or bucket? Yeah, I'll fail. At any rate, you can generate aggregable percentile approximations and things like that from Prometheus. So all good stuff, and you can hook Grafana up to Prometheus or to anything else and create graphs in Grafana with this nice little WYSIWYG thing here. So I can take that same count over here and generate the same looking dashboard over here. Last 5 minutes. Yeah, so you see kind of the same. Oh yeah, that's right. I didn't even remember this. My load test is oscillating between 200 requests per second and 100 requests per second. And you see that nicely there, throughput. Any other questions on this stuff?
Sorry, it's really the same question. Was
Yeah.
there a way that correlates between like your long running request and then like what it is
and what it is in logging.
So, like, because we were talking about like tracing earlier. So,
Yeah.
Yeah.
I mean, debugging why something is happening is always going to be kind of a separate function.
Yeah.
These are unfortunately on different. If I could put these on the same scale, you'd see it differently. But yeah, so you would use a performance tool like Visual VM or one of those kind of things. I don't know why I can't think of the one I use all the time.
I guess I'm just saying,
but-
would you be able to use something to say, so this request, it lasted 1 second or 200, like.
And then try to correlate that back to a trace.
Yeah.
Yeah, and that's going to be distinctly where that's why I said it's more like a line and a point than it is a triangle.
Yeah.
Metrics are going to kind of like aggregate up all the things that are happening and give you some math about it. And tracing would be kind of like the other thing.
Okay.
So yeah, they're really, because when you ship a metric to the back end, you lose the individual samples and you just get the overall behavior.
Yeah.
And to ship the individual samples would just be overwhelming.
Or would Zip be able to set up to do that? Because I know the SAM trace but.
Yeah, it's one of those things that you would do both. You would trace a particular block of code, but then you would also record metrics on it. So you would use the metrics to set up alerts to wake you up and say, hey, something's wrong. Here's when it happened, and then you go look for the trace. And that would be one that you go look for your logs, you go look for your trace, or you kill something. Like at Netflix all the time, I would always horizontally scale services, and it isn't unusual for one service to go bad first because it overwhelms a cache or something like that. And it's always symptomatic of like when this one goes bad, you can guarantee the other 10 are going to go bad eventually. But right now my users are experiencing pain, and the metric shows me that this particular instance is causing them pain, and I can just shoot that one. And then it gives me time, it gives me breathing time to then look and say, okay, all right, user pain temporarily alleviated, now what? And that's when you dig into traces and logs and local testing and whatever else you got to do to get it fixed. Or you can just keep shooting them every, 10 minutes, It's, oh, yeah. And I like to say about Netflix, it's kind of weird. They were really good at this stuff. They had the automated canary analysis, all that great stuff. And it had a weird perverse incentive, like they were really bad at unit testing. You might be surprised to hear. Because frankly, it didn't really matter. Like you just roll a bunch of new code, slap it into production, and then the automated canary analysis tool will go, whoa, this thing is failing like crazy, and then shut it down. And so, the incentive to get it right the first time was actually lower. Oddly, it created this weird organizational incentive, which, but at least they knew what was going on. And what I fear about the looking at average and things like this, I call it, or I take a phrase from somebody else, I call it like blindfolded with the lollipop. That's how I feel like we all are. Like, we really don't know what the heck is going on because we're looking at the average and we don't know what the other 50% of our users are experiencing. But we have a lollipop because we have like a pretty little dashboard and we feel good and we think like we really know what's going on and we really have no idea. And that's, in some ways that's worse than not knowing at all. But anyway, that's what I've got. So, any other questions? Yes, sir. Yeah. So the question was, walk through the code to create the timer. Some things Spring's going to make it too easy for you. Like, we're going to automatically time request endpoints for you. But if you want to do one manually, I'll just create just kind of one inline here. There's a couple ways you can do it. For the simple case, you can say, my timer, and I can start adding tags here. I can say John's Mac or something like that. And this could go on, of course, to incorporate other tags. And so we've got little types like, let me go to presentation mode again, sorry. And we've got neat little facilities for, doing this with just recording this specific time or to do something inside of here, and I'll just time the surrounding result or return the result from it, or et cetera. And so we've got a bunch of different types. So we've got counters, very similar interface, distribution summaries, we talked about that. And then there's an alternative API if you want to get fancier, and this is what we're doing when we provide out-of-the-box support. So we provide out-of-the-box support for things like Guava caches and EH cache and Hazelcast and Spring integration and CPU level metrics and memory and GC collection. Crazy stuff on GC collection. I think Hikari CP has already introduced this into their main line, et cetera. It goes on. But you could do this as well. And you could get real fancy on. And you could say, I'm going to provide a description for those, like, this is timing blah. And I could say, I want to ship percentiles from here. I want you to ship this percentile, and I'm going to set expectations around. Of course, these are all optional. Best case scenario would be this, and worst case scenario is 900, which we saw earlier. Which just makes this internal storage more efficient.
So you're showing us how to do this in Java?
Yep.
But,
Yep. And this is a Java-based thing.
Okay.
Yep.
There's not just a Spring Boot properties that you could set up that.
Yes, sorry. So, yeah. So, like, in this case, you could interact with the timer this way. And, the feature there's a guy working on as we speak, actually, from Domo, would be that you could, define all the rest of some properties. And that the mechanism would look similar to the way you can control logging levels in Spring, where you can wildcards. You can say, like, for everything that starts with my dot, I want you to publish the 95th percentile, those kind of things. That'll be pretty neat. And that'll help you, like, selectively disable metrics that are coming from core libraries as well. Yeah. Does that kind of make sense? Or?
I saw an annotation in one of your other.
Yeah.
What was that?
Really, the only one that we have is just this @timed. So you don't have to inject a registry and then create the timer, et cetera. And so we're going to automatically time things like requests and Spring scheduled methods, I guess you could say. But you may have other blocks of code you specifically want to time. You could do that if it's at a method level.
Is that only when does that automatically timing request come in? Like, is that only 2.0 or is that also in 1.5?
So what we have is it's in 1.5 as well, to answer the question simply, but why do I keep winding up on that one? We have a Micrometer core, of course, with the main SPI. We have implementations, like, for each of the backends. And then we also have a Spring Legacy module. And so the suggestion is going to be, if you're back on Spring 1.5, just add Micrometer Spring Legacy, and then all the stuff you get in 2, you'll get in 1 as well. Just kind of backporting it without having to change the code. Yeah, that's good. Yeah, keep going.
So what about, so I know these requests come in, what about like built-in timers and Spring data?
There aren't any yet. That could be something that we look at in the future.
I know, like, one of the things that we've used in the past is like slow query reports out of like the context
Mm-hmm. Mm-hmm.
That's like all we got.
I know.
Most times that comes out of the box. It's like, oh, okay, cool. Well, this retro for everything.
Right.
And then you're like, just skewering.
You're better than some, believe it or not. I mean, like, seriously, and this is, again, the blindfold with a lollipop. Sometimes just blindfold and sometimes blindfold with a lollipop. Some people are looking at just, like, heap and CPU performance. It's like, making decisions on that. So, yeah, it's kind of nuts. But, yeah. What other questions can you come up with? Or if there's none, feel free to ask me something after, too. You don't have to. Yep. Thanks for coming out, guys. Putting up with it. Appreciate it.